Alright, ladies and gentlemen, your final lesson on scatter plots. Today it's going to be about scatter plots and trend lines. So if you haven't already, fill out your table of contents. Today is April 13th. You're putting in your title, scatter plots and trend lines, and you will be taping your notes into page 95-96. If you haven't taped the other days because we were in the library, today is the day. Get it in there. Okay, so your note sheet for today, you've got some vocabulary to fill in. When scatter plots demonstrate a linear relationship, a straight line can be used to show the general pattern of the data. This line is called a trend line or a line of best fit. It's a straight line that should lie as close to possible to the points of the data in the scatter plot. So a trend line is going to follow the trend or the pattern of the data that you see. We practiced looking at points the other day about scatter plots when the points increase from left to right. This has a positive slope. This trend line is not drawn well because it is totally going against the points that we've been given. So this is not a good trend line to draw. The points have a positive trend and the line is drawn with a negative slope, so that is not correct. The second example is a very good example of what a trend line should look like. The trend line is as close as possible to the points and you're kind of splitting the middle between them. So that is a good trend line. It's as close as possible to getting to those points. The next example is close. As you can see, the trend line goes through a couple of the points, but it's way far away from these points on this side. So this is not a good example of a trend line because the line is actually above most of the points that we've been given. It would be better to tip it down and go through the center like this example. This example has the line going in the correct direction, but again, it only goes through these 3 points, and it's farther away from these other ones than we would like it to be. So a better trend line would go right through the center of all the points that we have. It needs to go as close as possible to the points in the scatter plot. Now, as you can expect, what we were working on earlier with graphing and writing equations is that you can write the equation of a trend line. What you do is you find any 2 points, and you could set up a rise over run slope triangle to find the slope, you could use the slope formula, but typically when you have the graph in front of you, you can do your slope triangle. After finding the slope, you can look at the y-intercept, or you can look at the y-axis to find the y-intercept. Then you'll write the equation in slope-intercept form. So remember, it's going to be in the format y equals mx plus b. So we're going to practice a couple examples together, and you're going to try some after. So we have to be careful to make sure we're using points that are actually on the trend line. So you're going to have to make some yourself. When you connect them, remember you're trying to make a right triangle, which is called a slope triangle. The right triangle helps you figure out what your slope is going to be. We need our rise amount and then we need our run amount. So if you're starting at this point here and you're rising down 1 box, you need to make sure you use -1 for your rise. And you need to make sure you use 3 for your run. So that's the slope. The next thing is you're going to locate your y-intercept. This is easy because your line should go straight through the y-intercept. So what we found is that this line crosses the y-intercept at +8. Putting that information together in slope-intercept form, we're going to write our equation y equals, and we're putting our slope, -1/3 x, right here. And we're putting our y-intercept at the end, +8. Looking at the next question, we have to identify 2 points that are on the line. And as you can see, the trend line goes through the points, but it doesn't actually intersect any of the points. And that's okay. We know that happens. So what we're going to do is we're going to locate 2 points that cross the grid and also are on our line. And these 2 points are good points to use. Now, be very careful with the slope triangle because you do have 1 box that you're rising up for the slope triangle, but that 1 box, you see, has a very different scale than in the last example. The last example, each box stood for 1 unit. In this example, each box stands for 25. So we actually have a rise of 25 units, and we have a run of 2 because the units on the bottom are just 1 unit each. If we divide that up, we get 12.5 for our slope. Now for the y-intercept, you can see it crosses at 100. So putting that together, we have our equation of a line y equals 12.5x plus 100. For the third example, again, we need 2 points that don't have to be data points, but they have to be points on the trend line that also cross the grid. So if you choose these 2 points, you have your slope triangle. And looking carefully at your scale, these units, it looks like they went by 5, so each box represents 5. So if we go down 5 and 1 more, we go down 10. And we have a run of 1. So our slope is -10. We have our y-intercept right here, which would represent our 45 for our y-intercept. And again, putting it together, y equals -10x plus 45. For number 8, to find the slope of the trend line below, Riley chose the points 180, so we might want to mark that a little bit darker, and 230. So if these are the 2 points that Riley used to find the slope, would this end up being the correct slope of the equation of the trend line? The problem with this is those 2 points are not actually on the trend line. If you're trying to find the slope of the trend line itself, you would need to find 2 points that are actually on the line itself. So this might estimate the slope, but it will end up being a little bit steeper. So the points we want to use, again, have to be on the trend line. So this would be a good one, and this would be a good one. So that looks like a negative, let's see, 1020 for our slope. And it looks like we're just going to have a run of 1. So we've got -20 for our slope. We've got our y-intercept. It looks like it's crossing at 90. So if we put that together, y equals -20x plus 90. For number 9, we want to see which of the following scatter plots could have a trend line with the equation of y equals 2x plus 5. We have to look carefully here because we know from this equation that our slope is a +2, and this will immediately eliminate the choices of A and D because their points are headed downhill, which would indicate a negative association or a negative slope. The last 2 examples both have a positive association. They're both going uphill, which would represent a positive trend line. But this one seems to be, if you were to sketch it in, it may even intersect 0, 0, which would not give you the y-intercept of +5, which is kind of what they're indicating in this equation. So I think the best bet would be choice C, would have the slope we're looking for, and it would have the y-intercept that we're looking for. For number 10, Mrs. Hamilton surveyed some of her students by asking how many minutes they spent studying for the math test and the score they made on the math test. The results are shown below. So you can see how long they studied along the x-axis, the actual test scores along the y-axis. If we need to find the slope, we will do very similar to what we did before. We're going to locate 2 points on the trend line itself. They do not have to be data points. They just have to be points that cross the grid lines of the trend line. And then we're going to look at our rise and our run. We have a rise of 1 box, which according to the scale means that we're going up 10 points. And then if we look at the x-axis, we have 3 boxes, which on this scale represents 5, 10, 15. So 10 over 15 can be left, or you can reduce it to 2/3. It's up to you. Part B, what does the slope mean? Well, if you use the labels in the equation, we have test scores that are increasing 2 points for every 3 minutes. And if you didn't reduce your slope, you would say the test scores increased 10 points every 15 minutes of studying time. Y-intercept, remember, can be found visually just by following your trend line down to the y-axis. We have it crossing at 60. And then what this means is if we spend 0 minutes studying, we will end up with a test score of 60. Putting that information together, we have our equation y equals 2/3 x plus 60. Remember, if you didn't reduce your fraction, you can leave your slope as 10 over 15. To summarize today's lesson, you're going to use slope and y-intercept, very similar to what we did when we were working on graphing and functions. You're going to find your slope, you're going to find your y-intercept, and you're going to put the equations together with the two pieces, y equals mx plus b. Now, what I'd like you to do is practice these 4 examples on your half sheet. When you're finished trying each equation, or each scatter plot's trend line equation, remember you need a slope and a y-intercept, and you need to write the equation of the trend line on each line. Pause the video while you do that, and then when you're finished, you can play to check your answers. Okay, checking your answers to your half sheet. For the first equation, you have a slope that is -1/2, and you can see that if you choose these 2 points for your slope triangle. You have a y-intercept that's +6. For this equation, you have this point and this point that could be chosen for your slope triangle. And remember to take a look at your scale. Each box actually represents 50 units, so this is an increase of 50 over 2. 50 over 2 reduces to the slope of 25, and I think you see visually that your y-intercept is 150. This one's a little tougher to get a piece of the slope triangle going, so if you look at those 2 points, I think you'll see the rise of 10 and then the run of 3. We don't reduce it necessarily if the numbers do not reduce nicely, so we can keep it the slope of 10/3. We have our y-intercept of 20. And for the last one, we have an intercept here, and we have another one here. So we can see in this very, very small slope triangle, we have a rise of 25, a run of 1, intercepts at 0. Notice we don't put the +0 at the end of the equation if we don't have to. Now, what you're going to do is you're going to tape in today's notes. Here's the large paper that you're going to fold in half and tape in so it still opens. Here's the half sheet that you just practiced. That'll tape into page 95 and 96. Quick reminder, if you didn't tape in your notes from the previous 2 days' lessons on scatter plots, here's a picture of what page 93 and 94 should look like. We did this lesson on Tuesday, and it was all about constructing scatter plots. You had to take notes, and then you had to do some practice problems on it. And when we first started scatter plots, here is what your notebook should look like, page 91 and 92. This is when we first learned about scatter plots and association.